Hello, Pre-Calc BC. So today we are going to be rotating conics, and we will do each of these parts for both problems. We're going to start with the problem we did not begin with in class. So if you would like to switch to or move to later in the video to find that hyperbola problem we began, you are more than welcome to. Our number one, we're actually going to do a different problem that's from what's on your note sheet, so just go ahead and write this one down. If you already started that other problem, that's fine. You can just find a different sheet of paper to do this one on. So, alright, step A is to identify the conic section. We will do that by doing our b squared minus 4ac. And remember, your a term is what's in front of your x squared. Your b is what's in front of your xy, and your c is in front of your y squared. So this is going to be root 3 squared minus 4 times 5, which is 3 minus 80, which is a negative 77. That is less than 0, so we are dealing with an ellipse. Alright, so that was pretty painless. Part B, determine the appropriate rotation formulas to use. So this is where we're going to find theta first, and then we're going to have to plug that into our x and y formula. That will give us the rotation formulas that ultimately, in letter C, we will end up plugging back in to our original equation. Okay, so cotangent of 2 theta is equal to a minus c over b, which is 4 minus 5 over root 3, which is a negative 1 over root 3. Okay, this hasn't happened before. We have not had a negative cotangent. Well, we've had a negative cotangent, in the past, but we have not had one yet for rotation of conics. So a rule of thumb, and your book goes into an explanation for this, but just based on how much time this video is already going to take, I'm just going to give you the information. You're welcome to look at the reason in your textbook, section 9.5. Whenever we have a negative cotangent, your angle is always between 0 and 180 degrees. Okay, so basically you're dealing with quadrants 1 and 2. Because cotangent would also be negative in quadrant 4. So don't worry about quadrant 4. We're just worrying about quadrants 1 and 2. The reason I say quadrants 1 and 2 is because maybe I should say 2 theta here. 2 theta might be in quadrant 2, but when you divide it by 2, you might end in quadrant 1. Okay, so I'll say 2 theta is between quadrants 1 and 2. In any case, here's what I'm trying to say. Unit circle. This is 30 degrees. You would be at root 3 over 2, 1/2. And at 60, you'd be at 1/2 root 3 over 2. The location where my cotangent is 1 over root 3, remember cotangent is x over y, would be 60. Okay, but since you're dealing with a negative, we can't be in quadrant 1, we have to be in quadrant 2. All right, again, not quadrant 4 based on this information up here. So the 60-degree angle in quadrant 2 would be 120. So that means 2 theta is 120, and then when we divide, you're at 60 degrees. Okay, so that is theta. Okay, so just remember, anytime you have a negative cotangent, worry about your top 2 quadrants, and then when you divide by 2, you will end back up in quadrant 1. All right? Okay, so we're not done with part B yet. Now we have to do our rotation formulas. So x and y formulas, you do have to commit these to memory. I will not give them to you on your quiz. X is x prime cosine 60 minus y prime sine 60. And cosine of 60 is 1/2. So that's 1/2 x prime minus sine of 60 is root 3 over 2. And then y is, it's kind of the reverse, x prime sine 60 plus y prime cosine 60. And I mean, you're still dealing with 60 degrees, so really what's happening is your coefficients are switching here, because sine of 60 is root 3 over 2 plus cosine of 60 is 1/2. All right, so those are your rotation formulas, and that means we are going on to part C. So part C, rotate the axes so that the new equation contains no xy term. This is when we're going to take x and plug it in everywhere you see an x up here, and we're going to take y and we're going to plug it in everywhere we see a y up here, and we're just going to go really slowly and carefully and write neatly for your pre-calc teacher who has to grade close to 60 of these. Okay, so let's do that. 4, and I'm doing 1/2 x prime minus root 3 over 2 y prime, and I'm squaring that. I guess I don't really need the brackets there, but oh well. Plus root 3 and x times y. Oh, I might have caught that up here. That's a y. Yeah, that would be bad. Okay. All right, so that's your root 3 xy plus 5, and we're squaring y. And everyone's favorite part, add the 77 over. Hooray! All right, so now I'm going to keep with the method of just simplifying one part at a time. So I'm going to bring down my 4, and I'm going to FOIL this whole thing out first. So 1/2 x prime quantity squared is 1/4 x prime squared. Okay, and then for your middle term, you are multiplying these two together and doubling it. So 1/2 times root 3 over 2 is root 3 over 4. Double it is 2 root 3 over 4, which is 1/2 root 3, or root 3 over 2. Okay, so again, that's root 3 over 4, but you doubled it, so that's 1/2 root 3, which I'm writing like that. And don't forget your, oops, that's pink, x prime, y prime. And it is a minus. Okay, plus you're squaring your last term. Root 3 over 2 squared is 3/4 y prime squared. Okay, and then I'm going to keep going. All I have to do now is distribute the 4, which actually turns out quite nicely because 4 times 1/4 is just 1. So I have x prime squared. 4 times negative root 3 over 2 will be negative 2 root 3 x prime y prime, and 4's cancel again, plus 3 y prime squared. Okay, so that part's done. Now, this is the part you need to be careful about. Because the one we started in class, you had difference of squares, and it was very easy to FOIL, and you had no xy term. But that is not what is happening here, because your coefficients for your x's and your x's and for your y's are different. So this is just regular FOIL. You just have to FOIL this like usual. So that means you have a plus root 3. Okay, and then you've got 1/2 times root 3 over 2, and that is root 3 over 4 x prime squared. You have 1/2 x prime times 1/2 y prime, which is 1/4 x prime y prime. Then you have root 3 over 2 times root 3 over 2 with a negative, which is 3/4 x prime y prime. And then you have root 3 over 2 y prime times 1/2 y prime, which is root 3 over 4. And it is a minus. Root 3 over 4 y prime squared. Okay, so you may notice that you have two x prime y prime terms. You are welcome to simplify this now, or you don't have to. Some people might think, okay, well, I'm going to have to combine a bunch of like terms anyways, so I might as well just wait till the end. Or you're thinking, I really don't even have enough space in my paper right now, so I should just combine them now. It's up to you. 1/4 x prime y prime minus 3/4 would be negative 2/4, which is negative 1/2. So I'm just going to kind of write that here. All right, and then I'm going to go ahead and distribute my root 3 to all of that. So root 3 times root 3 over 4 is just 3/4 x prime squared, and I'm going to move this over so I have more room. And then I'm going to do root 3 times the negative 1/2. Okay, again, you can distribute to each of those if you want. I'm just going to do this. Root 3 times negative 1/2 is just negative root 3 over 2 x prime y prime. And then I have root 3 times negative root 3 over 4, which is negative 3/4 y prime squared. Okay, so this is your second part, this is your first part, and we have one part to go, which is good because I don't have a lot of room left. Okay, this guy, we got a +5. This we're just going to FOIL out. Root 3 over 2 squared is 3/4 x prime squared, plus multiply these two together and double it. And let's see, root 3 over 2 times 1/2 is root 3 over 4. Double it. Okay, it's the same as it was before. So root 3 over 2. Root 3 over 2, and that's x prime y prime, plus 1/2 squared is 1/4, and you've got y prime squared, equals 77. And then we will distribute the 5. So that's 15/4 x prime squared plus 5 root 3 over 2 x prime y prime plus 5/4 y prime squared equals 77. And that's your third part. And this is where you cross your fingers and hope that your y primes, or excuse me, your x prime y primes cancel. Okay, so let's see here. We have a negative 2 root 3, a negative root 3 over 2, and a 5 root 3 over 2. Well, already they all have root 3's, so that's a good sign. So I'm just going to ignore the root 3's. You have negative 2 minus, this is a 1/2, plus 5/2. And I'm going to erase this. I'm just showing my work here. So, oops. So that's this. Negative 4 minus 1 is negative 5 plus 5 is 0. Hooray! All right, so all those are going to cancel. They all have root 3's, so there's no reason to think about those when you do your work. It's just like they were x's. So in any case, your root 3's cancel. That's exactly what we wanted to happen. So now let's combine our x prime squareds. You have 1 plus 3/4 plus 15/4. So that's, let's see here, 18/4 plus another 4/4. So that's 22/4, which is, I believe, 11/2 x prime squared. Feel free to use your calculator if you just don't want to deal with the fractions. Okay, you've got enough going on. And then we'll do our y's. You've got, that was there, 3y prime squared minus 3/4 plus 5/4. And that should give you 7/2 equals 77. Okay, but you're not done. We have to divide by 77. And you would just do that like this. Oops. Come on. There we go. And that is 1/14. So x prime squared over 14 plus, do the same thing with 7/2 divided by 77 and math bracket, and you should get, excuse me, y prime squared over 22. Don't forget your equals 1. And that is part C. Okay, take a breath, stretch. Okay, on to the graphing. So you'll notice we found out at the beginning this was an ellipse, and we can tell it is an ellipse. We have both plus signs. Remember, with ellipses, your a value is based on which one is bigger. So our a value is going to be root 22, and your b value will be root 14. And if you want, you can just find your c value now so you don't forget. With ellipses, c squared is equal to a squared minus b squared. 22 minus 14 is 8, so c is going to be root 8. All right, and let's draw and discuss our graph. Remember, discuss your graph means the way of saying write all pertinent information. Okay, so here's my x, y coordinate plane. Remember, our theta is 60 degrees, so we have rotated 60 degrees. This doesn't need to be perfect. Just do the best you can. I'm going to use gray here. Oh boy, I'm having a hard time drawing a straight line through the origin. We'll go this way. Okay, we'll just pretend that's straight. It really should be dotted, but it's going to be good enough. Okay. Your center is always at 0, 0. Root 22 is about a 4.69, and root 14 is about a 3.74, and root 8 is going to be a little less than 3. So root 22, that's in your y direction, so you're going up about 4.69. Again, let me label these. This is your x prime, this is your y prime. So when I say up, I mean in the positive direction on your y prime axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're going to make your own tick marks. And I'm just going to go here. Okay, and then root 14 is your x radius, so 3.74, that's 4, about 4 in the x prime direction. All right, and then this is an ellipse, so now we will just connect those. Okay, and don't forget about your foci, root 8, and that's going to be in the y prime direction because the foci are always on the major axis. So that's here and here. Okay. So now we just have to list everything else. Center I got. Vertices are going to be plus or minus root 14 comma 0 because I moved to the left and right, root 14. and then also 0 plus or minus root 22. Because I went up and down along my y prime axis. So remember, these points are always based on your new axes. Okay, and then foci. Again, up and down along the y prime axis, so that would be 0 plus or minus root 8. And that is part D. That is everything that you need to show for an ellipse. Okay. Let me just make sure there's nothing else I wanted you to do. Nope, that's it for part D anyways. So that brings us to part E, and it looks like I just have enough room right over here. All right, in part E, I actually gave you the directions for what you're going to do. This isn't what it's going to say when you do your quiz. This was giving you a little more detail. It says, state the equations you would use to verify the graph in part D on your calculator. Okay, that is what it's going to say on your quiz. The way you do that is by rewriting the original equation in descending order for y, and then solve using quadratic formula. Make sure to write both equations. Okay, so I can hear you sign through the screen. Don't worry, we're not going to make this crazy, okay? Or, you know, crazier than we have to. So the first thing you're going to do is you're going to take this whole thing, you're going to rewrite it in terms of y being first. So this is written in descending order for x. X squared, then your xy, then your y squared. You want to basically flip these two. All right, you want the y to be first. So that's 5y squared, excuse me, plus root 3xy plus 4x squared minus 77 equals 0. You do want it to be equal 0 because when you do quadratic formula, you have to have the equation equal to 0. Now, here's where it gets a little weird. Your a value, so now we're doing everything in terms of y. So your a value is what's in front of y squared. Your b value is what's in front of y. So the b is this whole root 3x, and that x is not underneath the root. And then your c is this whole leftover part. Okay, so we're going to say y is equal to opposite b, so that's this, plus or minus the square root of b squared minus 4ac all over 2a. And then what you need to do is tell me what you're going to type into y1 and y2 of your calculator. Okay, this is how you'd actually graph this with your calculator. So all you're going to do is break this apart and give me the plus version and the minus version. And you can simplify or not as much or as little as you'd like. So here's what I usually do. I square this part. So that would just be 3x squared. And then I multiply these two things together. That's how far I go. I don't bother distributing and combining like terms. The only reason you would really want to do that is if you think it's going to be faster to type into your calculator. Okay, so that's y1, and then y2 is just this with a minus. Okay, and then this is what you're going to give me as your final answer. If you can go straight to that and don't need to show this intermediary work, that's fine, or intermediate work. But this is right here what I want. Excuse me. Okay, so what does that actually look like? Well, I already typed into my calculator. So that's what it would look like. Oh, that's so much fun to type in. And then when you graph it, you get an ellipse that's been rotated. Hooray! Okay, so you don't actually have to type it into your calculator. It's just this is how you would do so. All right, so there you go. That's your ellipse. Now I'm going to redo the hyperbola problem that we began in class, and then I will finish it as well. Okay, so you're welcome to re-listen to this part, or I'm just recording it for myself. Lucky me. So, okay, part A again is identify the conic, and we already know it's going to be a hyperbola because I just told you, but we do that with b squared minus 4ac. And again, for this, your a value is in front of x squared, your b value is in front of xy, and your c value is in front of y squared. Okay, the only time you reorder it and you change your a, b, and c is for that last part when you want to graph with your calculator. And we have to do that because your calculator is y equals, so we have to look at everything in terms of y. Okay, so all right, b squared is negative 4 squared minus 4, 1, 1. This is 16 minus 4, which is 12. That is a positive number, which makes this a hyperbola. Okay, part B, we are going to determine the appropriate rotation formulas to use. So I will use my cotangent of 2 theta equals a minus c over b, which is 1 minus 1 over negative 4, which is just 0. All right, so where is cotangent 0? Well, that's when x divided by y, or cosine divided by sine, is 0. And that's going to happen up here at 90 because you're at 0, 1. So 0 over 1 is 0. So 2 theta equals 90. That makes theta 45. So that's what we're going to use as theta for our rotation formulas. Okay, time to do our rotation formulas. X equals x prime cosine 45 minus y prime sine 45. And because both cosine and sine of 45 are root 2 over 2, this is where we want to pull the root 2 over 2 out, and you'll just have x prime minus y prime in parentheses. This will make our life easier when we have to FOIL. And then y is equal to x prime sine 45 plus y prime cosine 45. And again, it's pretty much going to be the same thing like it was before, only here you do have root 2 over 2 for both, so we will pull the root 2 over 2 out. And you have x prime plus y prime. All right, so those are your rotation formulas. Now we get to the fun part, haha. Okay, so we're going to plug this whole thing in for x and this whole thing in for y. Root 2 over 2. Okay, so that whole thing is being squared. Notice this is different from the first one because here the root 2 over 2 is on the outside because we pulled that out, and here it's on the inside. So this is not like having this 4 out front. Okay, the 4 isn't distributing until after you square all of this. But here, this whole thing is x, so the root 2 over 2 is getting squared as well. So just be careful of that. Okay, minus 4. I'll leave this. 4x there's x and y. All right, there's 4xy plus y squared and add the 3 over. Okay, here we go. All right, we are squaring root 2 over 2. That is 2/4, which is 1/2. And then you have x prime squared minus 2x prime y prime plus y prime squared. And then I am distributing the 1/2. Okay, and that's the first part. The second part, if you'd like, you can multiply all of these together right now just to be done with them. Root 2 over 2 times root 2 over 2 is 2/4, which is 1/2. 1/2 times -4 is -2. I'm still going to have to distribute that -2. And then x prime minus y prime times x prime plus y prime, because your x coefficients are the same as each other and the y coefficients are the same as each other, then this is difference of squares. All right, so that's different from up here. Up here, because your x's didn't match and your y's didn't match, you had to FOIL, like normal FOIL. This one isn't going to be as bad. So this will just be x prime squared minus y prime squared, because your x prime y prime terms will cancel out, because you'd get plus x prime y prime minus x prime y prime. And then we're distributing that -2. And careful, plus. This is something that I've done a bunch. I distribute wrong. This should be a plus here. Negative times a negative. I try to make the mistake so you guys don't have to. You know, I'm looking out for you here. All right, last one of these. This one, there's so much less to write than the other one. Okay, it's basically the exact same thing as the front. In fact, it will be. The only difference is instead of this minus x prime y prime, you're going to have a plus, because look, these are the same. But I'm going to show the work because that's how I roll. Plus 2x prime y prime plus y prime squared equals 3, and distribute your 1/2. All right, look at that. It all even still fit on the actual page. Okay, well, it didn't up there, but I'm impressed with myself. So now this is where you cross your fingers that your x prime y prime terms cancel, and they do. This one was much nicer than the other one. So now we'll go ahead and we'll combine our x prime squared terms. You have 1/2 minus 2 plus 1/2. And that is -1 x prime squared. And then your y's, you have 1/2 plus 2 plus 1/2. And that is 3. Equals 3. And then we will divide by 3. And I'm also going to switch my order because my negative should be in the middle. So that's going to be 3 over 3 is 1. So y prime squared over 1 minus x prime squared over 3 equals 1. And this does look like a hyperbola, which is good because that's what we said it was going to be. Okay, now we get to graph. Your rotation angle was 45 degrees, which I have an easier time drawing. Maybe instead of dotting, you guys can just draw the axes really, really, really light. Or see, I'm using a different color here. I'm not going to be picky about that. Just make sure they're both not like the same darkness solid line. Okay, and I would like to see them labeled like that. Okay, let's see here. So for hyperbolas, your a value is the first one. So a is equal to 1. Here b is equal to root 3. And because y came first, that means that this hyperbola will be going in the vertical direction, up and down, along the y prime axis. So, oh no, don't tell me. Please don't tell me you're not. Okay, we're back. We had a mini crisis when my OneNote shut down, but it came back and everything was still here. So I was really not going to record this video a second time. So, all right, what we are doing is we are plotting our a and our b value. Your a was up 1 and down 1 on y prime, and your b is root 3, and root 3 is approximately a 1.73, and so that's like pretty close to 2, because root 4 is 2, and so you're just a little bit below that. And then remember, this is a hyperbola, so you are not connecting those dots in an ellipse. You are making the rectangle. And I know there's a lot going on. Okay, so there's your rectangle, and then we're going to do our asymptotes. And your asymptotes are really there to help you guide the shape of your hyperbola. Okay, and then this is a hyperbola going in the up and down direction along the y prime axis, because again, your y came first. So it will look something like this. Okay. The last thing you actually need to have plotted on here are your foci. So c squared is equal to a squared plus b squared, which is 3 plus 1 is 4. So c is just 2. And again, that's going up and down on your y prime axis. So this was a 1, so there's your first foci at 2. That was a 1, and so here is that. Okay, so now we just have to list all of our important information. Your center is at 0, 0. Your vertices are at 0, 1 and 0, negative 1. Again, this is on your y prime axis. Okay, your non-vertices are at root 3, 0 and negative root 3, 0. Your foci were at 0, 2 and 0, negative 2. Your asymptotes, be careful with this because it's not y and x anymore, it's y prime and x prime. It's just y prime equals because your center is at 0, 0. So we just really need our slope. We went up 1 and over root 3. Okay, and tx is c-axis. All right, t-axis goes through the hyperbola. So that's the y prime axis, but it's a vertical line. So it's x prime equals 0. And the c-axis is technically the x prime axis, but that's a horizontal line. Okay, I'm saying horizontal line in quotes right now, air quotes, because it's not, it doesn't look horizontal, but again, it's been rotated. So if you turn your paper, it looks horizontal, but it's going to be y prime equals 0. All right, and that is part D. I don't know if I labeled that anywhere. Part D. Okay, so that's all that stuff. Last thing we have to do, we'll see if I can do it in under 2 minutes so that we are at about 40 minutes, is we have to write the equations that we would type into our calculator. So remember, what you're going to do is you're going to reorder your original equation with y squared first. So really your y squared and x squared are just switching places. So that will be y squared minus 4xy plus x squared minus 3 equals 0. A will be 1, B will be negative 4x, C is this whole part, x squared minus 3. A, B, C. So y is equal to opposite b, that's 4x, plus or minus square root of b squared, I'm just going to square that now, 16x squared, minus 4, a is 1, c is that whole thing, all over 2a, which is just 2. And then just make sure you write the y1 and y2, And you can just go straight to this if you want, because really I'm not writing anything that's very different. And again, you can feel free to distribute. You can simplify as much or as little as you want. I really do not care. At this point, you probably all want to cry, so sorry. Okay, so notice the only difference should be the plus and the minus. We've split this apart. And this would be your answer. So there you go, part E. So on your quiz, you will have one of these problems. It will either be a hyperbola or an ellipse. And you should expect it to either be something with a 45 degree, a 60 degree angle of rotation, or a 30 degree angle of rotation. If you don't get one of those angles, then something has gone horribly wrong and you need to figure out what it is. So hopefully this was helpful, and I hope you have a great weekend or a great Monday whenever you happen to be watching this. See you tomorrow.